Okay, so let's get started. Welcome, everybody. So my name is Xavier Coulon. As you'll probably guess very quickly, I'm French. And today I'm going to talk about using Lambda expressions to query a data store. So I've been told yesterday that I should pronounce Lambda expressions or something like this. I used to say Lambda expressions. So if I make the mistake, you know that I'm talking about Lambda expressions. So I've been working at Red Hat for 3.5 years now. My main work is working on JBoss tools and Developer Studio. This is what I talked about on Monday. Today is going to be something completely different. It's a personal project that I started something like 1.5 years ago. And I'm going to show you today where I am now on this project. So what's the idea of this project? The idea is to use Lambda expressions. And why Lambda expressions? Well, Lambda expressions provide type safety. And when you write something, it's going to be compiled by the compiler. So you don't have, you have less risk of having something wrong at runtime. And the second thing is, with Lambda expressions, you are more going to describe the what and not the how, which means you're going to have a very concise expression, a very concise way to express what you want to query, what you want to do on your data store, or on a collection. Let's talk about collections. What you want to do on your collection, what you want to retrieve, what you want to filter, what you want to change. You don't have to write this complex for loops, etc., etc. So I was on my bike sometime like 1.5 years ago. And actually, when I do some sports outside, sometimes I get some ideas. And I was thinking about some personal project that I could start on. So my idea was to make, to build some kind of application where I could upload my photos, because I like to take, I like photography. So I wanted to get like a website where I could publish some of my personal photos. And so I thought, okay, MongoDB might be a good choice to store this kind of document where I would have some metadata, some title, location, maybe some tags, a few comments maybe, or description. And at the same time, I was thinking, oh, Java 8 is going to come. What could I do with Java 8? So it was before Java 8 was even released, like a few months before. And so I was thinking, oh, okay, maybe we can do something like using Lambda expressions to query on the data store on MongoDB instead of using, well, something more classic like the existing solutions that we have for MongoDB. So let's take another example now. Let's say I have a collection of users, and I would like to find a user whose first name is John and last name is Doe, or its username is JDoe. Why not? So we could have something like this. We have a user collection, and we want to filter. So we want to filter and apply this expression, first name, last name, etc. And then we want to do something like toList and retrieve a list of users. And the idea was, OK, can we do something like this? Well, we can do something like this with Java 8. You have your collection or your list in memory somewhere in your JVM. Can we do something like this with the user collection, which would be something, a collection of documents of user in MongoDB? So I came back home. I was pretty dirty. Yeah, I think you don't always see speakers with such selfies on the slides, OK? So, and I started this thing which I called Lambdamatic, because naming a project is something difficult. I came with this idea, and that's what I'm using now. So I'm going to explain how it works now. The first part of this presentation will be about the building blocks, how I can use Lambda expressions. So the first thing is we generate a meta model to write queries, and then we do Lambda expression analysis on this based on this meta model. So this meta model is generated just something very close to what JPA does, actually. So I guess you will be more or less familiar with this. So for example, we have this kind of class, a user with ID, first name, last name, username. We put a bunch of annotations on top of it. So I didn't use JPA annotations. I brought my own annotations. So it's basically just a couple of annotations. You have a document here where you can specify a collection, which is in this case users. I have document ID because ID here will be the ID of my document. And document field here for first name. I didn't put one on last name because it's something optional. And I put one on document field, which is you name, if you want to have something different between your Java code and your model in MongoDB. And as you can expect, we get something like this, Q user class, which has some public string field here with annotated with document field. And as you can see, we use the same, the variable name on the left side is used by default on the right side in the document field annotation. Otherwise, we take what was explicitly specified. So we have this query metadata class.
Why is last name annotated with document field on the right?
Because we didn't set any at document field annotation on the left, so we use it by default. We use the same name. Okay, let me explain. So first name here comes from, no, sorry, last name comes from the variable name here, last name. Okay, so we have this metadata class that has been generated, and since we do metadata, when we do class generation, we can do more than just metadata, so we can generate a class collection, which is something like this. It extends internal implementation from the library, so something like Lambda-matic Mongo collection EMPL. And it's, as you can see here, it's typed with user and Q user. So we have just a constructor, and then we inherit from everything underneath. So it's pretty simple. And since I wanted to do something that I would deploy on Wildfly, I have also a CDI producer, so I can inject my user collection later in my REST endpoint or service bin or whatever. Okay, so back to what I was thinking about at the beginning. We have this user collection here. We want to filter with some query, first name, some criteria, sorry. First name, last name, or username. And interestingly, what we can have with the API that I just showed before is the user collection is going to be the user collection class that we've seen before that has been generated by the class generator. And more interestingly here, we have this U variable here, which is not a type user, but it's a Q user. So we can write something like this. We can use, we can have first name here, which is a public field, and we don't have to do something like get username or get first name. So we have a syntax which is more concise, I think. So we can have some cool things with this kind of API where we have our entity model, and we have these metadata classes associated with them, but a slightly different API. And we can do things like geospatial queries, since that's something built in MongoDB. MongoDB has a way to query documents based on their location, and we can do something similar with this API here, with Java API. So let's take another example now. Let's say we have some bike stations, and like you want to rent a bike, like you can do in Boston, in New York, in Paris, or in other towns, in Lille, where I live. And these stations have their own location, of course. So we have a class location that comes from Lambda-matic with two attributes, latitude and longitude, very basic stuff. Since we have this bike station class, we can generate a Q bike station metadata class, which has a location field, a field named location of type location field. And finally, we have this location field type here, which is an interface, and it has a GeoWithin method. So this is an important point, actually. This location field is an interface. Actually, what I'm going to show you later is that we don't want to actually compute and perform geolocation, geoqueries on the Java side. We will just want to get, how can I say? We just want to write a query, and then we will get the meaning of the query and send it to MongoDB, and MongoDB will do the actual work. So we don't need to implement the GeoWithin actual code. We don't need to. I don't want to do this kind of thing on the server on the Java side because it may be wrong. Actually, maybe MongoDB has some different algorithm, and actually I don't need to do this because I don't have the data on the Java side. All the data is on MongoDB. Okay, so we have all these things together, and what we can do is something like this. We can say, okay, I want to find within an array of corners, which would be something like, let's say I have an application on the corners of my map, and I want to find all stations whose location is within the corners given in parameter. And then I want to return this thing as a list, just as this. Pretty simple, isn't it? Okay, so now we have something like an API we can start to play with. So the second part is Lambda expression analysis. Lambda expression analysis. Okay. Okay, so I was starting to prototype this thing, and I said, okay, no problem. I will take. So let's go back to this user first name, last name, username example we've seen before. I thought, okay, I will write a bit of code, and I will put just a breakpoint in Eclipse, and I will just look at what I have in this Lambda expression, filter expression here. And so I put a breakpoint, and if you are Eclipse users, you can see here we don't have any caret, or some, don't know how you call it, but basically there is nothing. There is no information here. You cannot see anything except this user service lambda $1 / something, which is actually not useful at all. So I was a bit depressed. So I did a bit of research, and actually what you can do is, if you use a functional interface which is serializable, so I made this kind of functional interface. I extend a predicate because I want to make a predicate, but it's serializable. I hope I pronounce it correctly. Otherwise, you see what I mean. So once you use something like this in your code, not just a predicate, but serializable, there will be, the compiler is going to compile your Lambda expression, and it's going to add some synthetic methods. One of them is a method named write replace here. So it's a synthetic method, so you cannot call it directly, you can do it with reflection. And once you invoke this method with your expression here as a parameter, you get something named serialized lambda. That's something that comes from Java 8. And the serialized lambda class instance will give you a bunch of information, including all these ones that have been highlighted. So captured arguments here, we don't have anything because we don't have any arguments coming from the outside of the query. But here we have this implementation class and implementation method name, which are shown here. And actually this is where Java compiler generated the method which corresponds to the Lambda expression that we are using. Okay, so that's a good thing. We know where to look at in our code, in our bytecode. We know where to look at for this Lambda expression, how it was converted from Lambda expression to bytecode. So the next step is reading the bytecode, of course. So reading the bytecode, this is something that you can have if you use a Java P command line with some flags like -s, -v, -c, I think. Okay, you get something like this. So if we look at this, we see some, I highlighted a few things. So we load, for example, a variable number 0, and actually this is index 0 here is a variable named u of type QUser. Okay, good. And then we access a field named first name. So this is going to be put in a stack, expression stack. And then we load a constant named John, which is put in a stack. And then we perform equals method. And to perform equals method, we need 2 arguments. So we are going to take expressions from the stack and execute them. So we are not going to execute anything here because, as I said before, we don't have any data in memory, okay? All the data is in MongoDB. So what we're going to do instead is reading the bytecode and trying to understand what the compiler would do if we actually had some things to give it, okay? So we can build something like abstract syntax tree while reading everything and trying to understand, following the branches. If something matches, something is equal, something is not equal, the compiler, oh no, not the compiler, sorry, the runtime is going to execute to follow some branches. And so from this kind of thing, we can build an abstract syntax tree, which is something like this, which is actually what would be executed. So for example, we would have something like, okay, first name is John and last name is Doe. Okay, return true, it matches. Or if it doesn't work, we'll try with username. If it's okay, we return true. If everything was wrong, was false, we return false, etc., etc. So we have something that is absolutely valid, okay, in terms of execution. But it's not exactly what the user wrote, okay? We want to find something, we want to capture the initial expression and send it to MongoDB. I'm sure if I send something like this to MongoDB, something like a long query, BSON query with all these characteristics, MongoDB will be able to execute it. But I want to send something which is more closer to what the user expressed. Okay, so the next step would be to thin out the AST. Something like we have a tree with branches, and some branch will return false, some branches will return true, and we want to keep branches that return true, which is exactly what we are looking for, okay? So we do this kind of thing, and we arrive with a long expression, which is what matches the data. Okay, so this is still good, but it's not good enough. So what we can do, we can try to further simplify this AST. Because, of course, you can see that, for example, first name equals John appears 3 times on this long expression. And we have the same thing for last name, which appears 2 times, and username appears 2 times. Last name appears 2 times, including once with a negative operator. So, okay, can we do something like this? Can we do something better? So I remember that when I was at university, I had a course about Boolean algebra, where you can do something like this and this, or this or this, etc., this or that, etc. So I looked at what algebra rules could use, and I found all these rules that I can use, actually. So I'm not going to go in details about this thing, but just a couple of simple examples. For example, if you have something like false and whatever, it's going to be whatever. If it's false and something, it's going to be always false, etc. If it's true and whatever, it's going to be always true, etc., etc. And so I started to do something like starting from this long expression that we've seen before, trying to find some patterns matching these rules, and then applying these rules to get something simpler, and then carry on until we have something that is as simple as possible. So it can be something like we've tried everything, or we found something that cannot be simplified anymore, so we stop with it. So to do this kind of thing, we put a score on every expression we have, and we try to find the lowest score for simplification. So it's been quite challenging. I think I've got a bunch of gray hairs because of this. But at the end, we started from this thing. We applied all the rules that we could, and we finished with something like this, which is the simplest form that we could find from what I've shown you before. And if you remember, this is what we had in our code before. So we started from a code written, compiled into Java code somewhere in a method of our class, in a somehow hidden method that would be called by invoke dynamic. And then we read the bytecode, we get an AST, we simplify as much as possible, and we get this AST, which is exactly what the user gave before. But it's an AST that we can manipulate then further. Cool. And I think I will have a drink as well now. So you may be wondering, okay, but what about performances? And that's a good question. So bytecode analysis is performed only on the first time that you invoke a Lambda expression, or that the code is going to be invoked at this place. And actually, well, on this MacBook, or yeah, on this one, parsing a Lambda expression and simplifying as much as possible is less than 100 milliseconds. It's even something more like 50 or 70 milliseconds. Then this AST is cached for subsequent calls. So you don't have to pay for this again and again. Okay, so it's like at Bootstrap or something like Bootstrap. It's going to be a bit expensive, but then it's going to be pretty fast. Something like, maybe we can say it's like a prepared statement or something like this. And also, what I didn't show here, we have some placeholders in this AST for captured arguments. So we didn't have any captured arguments here, like the values that we wanted to check, something like John, Doe, J-Doe, were all constants in the expression. But it could be some parameters that come from outside. As we've seen, for example, with the bike station location where the corners were external parameters, okay? And so we just have these placeholders, and when we want to invoke, when we want to search for bike station within some specific area, we just take this raw AST, apply the corners, and send it to the next step, which is what I'm going to talk about. So this is called managing data because, as you will see, it's not just about querying. Since I submitted this talk, I did a bunch of improvement. So it will be now more about managing data. So we have this AST, and we want to send it to MongoDB. So we are going to use a MongoDB Java driver because this MongoDB Java driver can do a lot of interesting things. It speaks BSON. It is able to connect to multiple MongoDB servers. And actually, I don't want to do this thing again. The guys at MongoDB do a very good job at this. So I just need to integrate with their work. So what we will do, and this is a cool feature of the new Java driver version 3, is that you can provide your own codecs in the driver when using the driver. That's something, so it's like pluggable codec architecture. And so we are going to use codecs to send Lambda expressions, to convert Lambda expressions into BSON document, which are our queries sent to MongoDB, and MongoDB will give us some results which will be converted into documents or entities, if you like. And this benefit is that we can skip the default codec. Since there is this pluggable codec architecture, we can skip the default DB object classes that the Java driver provides by default, which are, well, we can skip this part, so it's, I guess it's a benefit. So it's going to work this way, actually. We have our service layer here. We have some Lambda expression. So we are going to use a filter expression codec, which is going to convert this Lambda expression and do all the work I've shown you before to convert a Lambda expression into a BSON document. And then this BSON document is going to be sent by the driver over the wire to MongoDB. MongoDB is going to make his work. it's going to return a BSON document to the driver, which is going to use this time a document codec and convert this BSON document into one or more domain objects, which will be returned to the service layer. Okay, it's time for a short demo. Okay, so I need. Okay, so we have JBoss tools here, and okay. So we have first example here, which is, as I've shown you before, we are going to look for bikes in New York City, bike stations in New York City. I'm going to show you what we have here. Okay. And okay, here we have this example here. So we are at Manhattan, we have Central Park here. And as you can see, all the blue dots here are bike stations. And I'm going to clear the console here, so you can see what's going to happen. So we have this application running here, and I have a WebSocket connection with my server, which is running Wildfly. So I use a WebSocket connection, but in fact, I'm not really using dual channels or push messages. But the benefit is that I have some connection which remains open, and I can send a new location to the server, and the server is going to use this WebSocket connection to return a set of locations for bike stations. And so when I move the map here, you can see all these queries have been run on MongoDB, which is running on my laptop as well. And this is the kind of query here that is sent to MongoDB. Okay, so I send a bunch of locations, and I get everything here again. So this is all the bike stations that we have in New York City, if you ever go there. Okay, so let's just look at the code here for a second. So we have our endpoint here, which is going to retrieve, to be called, this method find bike station is going to be called with a list of corners, which are, at the beginning it was JSON document that had been decoded by my locations decoder. So we don't need to look at this code now. And we are going to call the storage service, which is with this find within method, which is actually what I've shown you before, where we look for bike stations which are in service and located within the corners of my map. Okay, and we get a list of this. Okay, back to the presentation. Okay, so I have three more things to show you. Yes, three. So the first thing is querying on arrays. So I'm not sure it renders correctly, but it's going to be something like the Inception movie, actually. So if you do query on arrays, you can do something like this. Let's say let's take a new example. I have a blog entry, which is a document in itself. Let's say I have a blog. Imagine, I don't, but let's imagine I have a blog. And I have blog entries, and each blog entry can have some comments. Some people may put comments on my article. And for some reason, let's say I want to find all comments whose author is anonymous and the date is less than 2 days ago. Let's imagine this thing. So what's going to happen with MongoDB actually is MongoDB is going to return it's not going to return comments whose author is anonymous and date is less than 2 days ago. It's going to return all comments. Oh, maybe no. It's going to return all blog entries which have comments written by anonymous or comments written by written less than 2 days ago. So it's not exactly what we want to do. What we want to do is have both criteria matching. So we can do something like this instead. And this is MongoDB has something similar. Okay, it's the way it works, and the way I use Lambda expressions matches this thing. So we have a first Lambda expression here, which takes a blog entry, and we are going to use comments. And on each comment, we are going to apply an element match operation and we will take every comment, and we will take comments whose author is anonymous and date is less than 2 days ago. So we have lambda expressions inside lambda expressions, like Inception movie. Okay, query projections. So the cool thing about MongoDB is that you can have large documents. It's a document store. So you can have something like up to 16 megabytes of document. One document can be up to 16 megabytes. So let's say I have a blog entry with a long article and tons of good comments on it. It can be very, very big. But if I have on a page, I want to see the list of my articles. I don't want to pull everything just to display title and date and author, maybe. So we can do something with projection where we can specify which fields we want to retrieve. So earlier, I talked about generating query metadata class. And this is not the only thing we generate, actually. We also generate projection metadata class, which is the reason why at the beginning I started with, I had just a query metadata class. So instead of having a Q prefix, I had underscore suffix. But it doesn't scale when you want to generate many metadata class, or 1 underscore, 2 underscores, and etc. It's not scalable. So okay, we have a blog entry, and now we have this abstract class p blog entry. It's an abstract class because we don't need to implement it actually. We're just going to use it as a way to write queries and convert it into BSON document sent, BSON query sent to MongoDB. So we have something similar as we've seen before, except that we use different types here. Now it's going to be projection field instead of just string field. That's the cool thing. When you generate many classes, you can use different APIs and do whatever you want for some specific use case. And so we have this pblog entry, which you don't really see except when you type you don't really notice that you manipulate something which is of type pblog entry. You just think, when you write your Lambda expression, you just think that you use a blog entry, not a pblog entry class. And we have this, again, it's just an interface with some static methods with annotations, class named projection. And we can do something like this. We can say, OK, we have this blog entries collection of documents on MongoDB. We are going to filter them because I want to find entry with ID 1, for example. And here, we say, OK, I want just to project these 3 fields. And this is what I'm going to retrieve. I will retrieve a blog entry which has only 3 fields populated, if you like. Everything else will be null. So that's something I didn't really mention when we compare with Hibernate, for example, is that there is no proxy around. You just get an instance of a class, and some fields have been filled. So it doesn't make any sense. Some fields have been populated, and everything else will be null. So that's the approach I have for now. OK. We can also do something like this. We can also project on arrays. So let's say, for example, that I don't want to pull all comments, but I want to put some specific comments that match some specific criteria. Once again, we can use projection, and we are going to give a new Lambda expression inside, where we can say that we want to include, so here we want to include, to get a first, we want to get a blog entry whose ID is 1. We just want author name, title, and publish date, and all comments from anonymous user less than 2 days ago. That's just a use case. OK, so we've seen a lot of things around queries. Now we can look at, I talked about managing data, so we can look at update operations. And of course, I have more metadata class. And this time, so we had Q, P, and now we have U. So it's going to be U as update, U blog entry. And actually, we don't, here you see we have the same type string here. Oh, it's a wrong color, but we have for simple types like primitive types, string, date, etc. It's the same thing. here we have something a bit different. We had a list of blog entry comment, and it's going to be a U blog entry comment array, because it's going to be an array in MongoDB, and we want to have some specific API on top of this. So we have this blog entry class, which has a list of blog entry comments, and blog entry comment is something like this. And what we can do, for example, we can say, okay, I have this blog entry comment that comes from somewhere. It's been submitted on the REST endpoint. And we can do something like this. We can say, okay, we have this. I want to update a blog entry whose ID is 1. And what I'm going to do is I'm going to set a new update date, last update field to new date. So it's a new date that appears within your Lambda expression. I'm going to increment the number of comments, and I'm going to push the comment that has been given here at the end of the array. And so you see, it's pretty easy with this kind of thing to specify the operation that you want to do. Once again, it's totally different from the way Hibernate works, where you make changes in your entity, and then Hibernate is going to, using proxy, if I don't make mistakes, it's going to use proxy to understand what the user did and what changed were applied and what needs to be sent over the wire. Here we specify exactly, okay, this is what I want to do on my entry. And well, it's Lambda expressions, and we have something a bit similar to the stream API here, where you can see filter and for each method. But the funny thing is you have this kind of similar stream API, but blog entries is not an actual collection of objects in memory. It's something in MongoDB. And it's time for the second demo, where we will see filter, projection, and updates. Okay. So where is... okay, this should work. Okay, so we have here, so we talked about a blog, so it's going to be the subject of this demo. So I have a super blog here with one entry, which is lorem ipsum. And we have here some content. So let's take a look at this first part. Okay, blog. So we have a JAX-RS endpoint. Maybe we can go there. And okay, so here, maybe we can start with the first one here. So this is what happens with this find whole method here is what happens when you want to display, when you want to show the first page. So let me go back to the first page here, where we just see title, author, and date. And this is what we are going to do. We are going to say, okay, we want to find all from this collection, and we want to project. Sorry, I'm going to move this. We want to project fields, and we just want to include author name, title, and publish date. And we get a list of this. And this is actually just what we want to send on the wire to the client, and the client is going to get the JSON document and just print on the screen, in the HTML page. Okay? So now we move here to this page. And this is this endpoint that is going to be JAX-RS endpoint that's going to be invoked. And so here we say, okay, we have this ID which is given when we clicked. This is the ID we have here, 1 in the location bar. So we have this ID here. Again, we want to do some projection. And this time we can say something different. We say, okay, we want everything but not comments. So because that's another way to express projections with MongoDB. So we exclude comments. We don't want to show them for now. And we want the first entry that matches this filter, just like the stream API gives you. And we get a blog entry. If we didn't get anything, we return a 404 response. Otherwise, we just send the JSON document. And now here, we can see all comments in a form. So we have 3 comments, which are here. So we have comments for a specific blog entry ID. And now we have something similar again, but we want to filter data from MongoDB, and we just want to include comments. So this time we just take the comments and send them over the wire. And so we have these things. OK, 3 cool comments. And now I'm going to add a new comment. I'm going to send it, and this is what. So I'm not already printing everything as a long query that will be sent to MongoDB, but you can see things that happen. And if I refresh again, so you can see now that I have 4 comments because I incremented the number of comments. And I have my comment here that appeared. And this was from the code here, from the post method. This is what I've shown, you've seen on the slides, actually. But I just received some data from a form parameter, with form parameters. And I said, OK, I want to set a new date for my last update because something changed in my blog entry. And I want to increment the number of comments because that's a field that I use to just count the number of comments. And I want to push a new entry on the array of comments. And so this is the end of the presentation. So the status of this project is experimental. I should probably release some 0.1 version soon. But for now, it's on GitHub. I could probably show this. So it's on GitHub under the Lambda organization. So if you think it's interesting, what you can do is, the best thing you can do is give it a try. So there is a README file where you can get you can see some of the things I explained here. You have some instructions to build the project. It's just mvn install, actually. It's very easy. You can skip the test if you don't want to run the test. And if you think it's interesting, you can, clone it, fork it, star it, make some pull requests, open issues, and we can discuss about APIs, et cetera, API and features. So that's it for me. Thank you for your attention.